Observer, something quiet has reached you tonight, and you weren't meant to pass this moment untouched. Something in the deep has led you here, as if the cosmos wanted you to hear what James Webb has begun receiving from 3i Atlas. What if a signal arriving across millions of years began showing patterns no natural object should produce? What are the odds that an interstellar body, silent, distant, unbound, would return data that bends every model we use to explain the sky? Let the noise around you fall away now. Picture only a faint pulse folded into radiation drifting through the dark toward us. Stay with me. Let's drift a little deeper. Something quiet has been unfolding above you, listener, and the moment you arrived here, the night seemed to shift ever so slightly, as though the sky itself had turned its attention in your direction. What we discuss now is not rumour, not distant speculation, but something occurring in real time, observable through lenses pointed at the dark and recorded by instruments that rarely err. Yet those instruments are whispering contradictions, and scientists find themselves pausing longer than usual, as if the silence between their thoughts has grown heavier than certainty. For days now, photographs have surfaced across private astronomy circles, images so recent they still seem to hold the cold of last night's starlight. They are not artefacts from past decades, nor misinterpreted relics of older missions. They appear precise, unexpectedly clear, for an object drifting hundreds of millions of kilometres away. And as these images spread through specialised spaces, they bring with them a faint intake of breath from those who have spent their lives studying cosmic light. Tonight, the universe whispers again. In the earliest hours of their appearance, discussions emerged not chaotic arguments, not speculation wrapped in fantasy, but grounded exchanges among people fluent in orbital mechanics, spectral fingerprints, and the quiet behaviour of distant snow-dark bodies. They adjusted brightness curves, recalibrated noise maps, and compared each frame to expected models. No one dismissed the images outright. No one accused them of being obvious fakes. Instead, a soft hesitation settled into the conversation, the kind that only arises when trained eyes witness something that refuses to fit into familiar frameworks. Everything about 3i Atlas has been peculiar from the beginning. Its detection arrived earlier than expected, its brightness changed in ways that defied comfortable explanation, and its colour shifted in sequences that forced researchers to revise assumptions more often than they preferred. Each scientific attempt to smooth irregularities only revealed new ones in their place. It is all right not to understand. Sometimes uncertainty is the most honest position a mind can hold. Somewhere beyond our reach, something ancient still moves. These leaked images now drift into that atmosphere, arriving in the wake of months of anomalies, already recorded in published data. Claims have emerged that the photographs reveal structural patterns sharper than any dusty coma should allow, subtle angles, repeating proportions, faint impressions of form, where form should blur and dissolve. Those trained in photometric enhancement dissect the pixels, carefully mapping gradients and marking edges not to sensationalize, but to understand. Silence is the universe thinking. Online discussions have taken on a rare clarity, calm, technical, contemplative. Amateur observers with telescopes of surprising capability compare their own captures to the newly processed images. Some see only haze shifting against the background stars. Others swear they detect boundaries that refuse to disappear even after aggressive noise reduction. The debate does not spiral outward. It folds inward toward precision, toward a discipline rooted in the long patience of those who study the night. Yet beyond those specialised circles, the wider world remains still. Mainstream outlets look elsewhere, driven by cycles that orbit more predictable concerns. An unanswered question could drift across the sky with the mass of a small moon, and still it might go unnoticed by those who do not look upward. But you, listener, arrived here. You feel the weight of this quiet moment, even if you cannot define why. Tonight the universe whispers again in ways subtle enough that only those who listen carefully will hear. Scientists describing 3i Atlas have chosen their words with measured restraint. Unusual, unexpected, inconsistent with standard models. None of it dramatic, yet the tension beneath the phrasing is unmistakable. They note shifts in colour occurring earlier or later than anticipated. They discuss brightness oscillations that fail to follow predictable thermal curves. They document water signatures behaving as though released from deeper reservoirs than the models permit. Small puzzles add themselves to larger ones until the entire dataset begins to feel like a quiet rebellion against expectation. And now, as November deepens, the object re-enters visibility after its brief disappearance into solar glare. Telescopes track its slow return, watching as it crawls out of the sun's brightness, like something awakening from long sleep. The first post-perihelion images often appear soft, unpredictable, yet these new photographs arrive with clarity sharper than expected. They reveal edges that should not have survived outgassing patterns, that should have dissolved under solar radiation hints of structure where chaos should rule. Silence is the universe thinking. The institutions that usually respond quickly to public confusion remain strikingly quiet. No confirmations, no corrections, no dismissals, just absence. A contemplative pause, the same kind that settles into a quiet laboratory near dawn when numbers begin resisting interpretation, leaving only the soft hum of machines and the slow, steady pulse of puzzlement. Somewhere beyond our reach, something ancient still moves. Perhaps the silence is caution. Perhaps it is reverence. Perhaps it is simply the recognition that some questions deserve stillness before they deserve words. For now, we stand within the gentle dim between answers and possibilities. The photographs exist, the debates continue, and the object drifts onward, trailing light through a vacuum that has never required our understanding to remain mysterious. It is all right not to understand. Sometimes the most profound truths begin as puzzles we do not yet have the vocabulary to name. What makes this unfolding story so unusual is not merely the photographs themselves, but the environment into which they arrived. Before a single image leaked, the astronomical community was already unsettled by weeks of data that resisted clean interpretation. The brightness curves of Thurati Atlas rose and fell with unsettling irregularity, as though some hidden rhythm beneath the surface refused to move in sync with established laws. Even the most seasoned observers found themselves staring at graphs longer than necessary, waiting for patterns that would not reveal themselves. Every comet carries its own personality shaped by ice dust and time, yet this one behaved like something reluctant to reveal its nature, shifting colour with a kind of quiet unpredictability. Reddish tones faded into muted grey. Grey gave way to hints of blue that emerged earlier than expected. None of these transitions were inexplicable on their own, but together they created a portrait of an object unwilling to settle into the simple category it had been assigned. In astronomy, the smallest deviation sometimes echoes louder than the largest impact. Professionals who normally speak with statistical precision began speaking instead of curiosity, inconsistency, and ongoing review. These are not the words of crisis. They are the vocabulary of minds standing at the threshold of something they know may take years to understand. The universe rarely reveals itself with clarity. More often it teaches through contradiction. And so the scientific community settled into a kind of attentive quiet, waiting for the next piece of data to tilt the balance toward understanding. Then, as Atlas disappeared behind the sun's radiance, the world entered a brief pause. Observers could do nothing but wait while the object crossed the region where sunlight overwhelms every instrument. This period, when a comet slips behind the star's blinding veil, has always carried a sense of vulnerability. The instruments fall silent, the tracking halts, and researchers find themselves suspended in uncertainty. It is a humbling reminder that even in an age of powerful telescopes, the cosmos still dictates the terms of observation. When the object re-emerged faintly visible in the pre-dawn sky, anticipation returned with it. Telescopes across the world prepared for new imaging opportunities. The expectation was simple: Atlas would behave like any comet after perihelion, brighten predictably, shed gas and dust, become easier to photograph and harder to interpret with the naked eye. But the first leaked images told a different story. They showed clarity where there should have been dissolution edges, where there should have been blur. Something beneath the coma appeared to endure where physics suggested it should vanish. To those who understand the fragility of such observations, the reaction was not fear but contemplation. How does a small, volatile object maintain the illusion of structure under the intense heat of the sun? How does something made of dust and frozen molecules present what appears to be stability? The questions were not accusations, they were offerings. In science, a good question is more valuable than a premature answer. Silence is the universe thinking. As analysts began comparing the leaked images to earlier verified ones from September, the contrast grew sharper. The object in the professional images looked soft, asymmetrical, and hazy features expected from a visitor shedding its layers under solar radiation. But the November images carried hints of symmetry patterns in brightness and persistence in shape that felt out of place. If the data were manipulated, the anomalies would have revealed themselves quickly, but what researchers found instead was uncertainty balanced on the edge of possibility. The online communities that first spotted the discrepancies responded not with haste, but with discipline. They applied sharpened filters, median stacks, colour extractions and Fourier transforms. Some enhancements weakened the features, others strengthened them. Even when patterns faded, echoes of structure remained. It was as though the light itself carried memories of a form reluctant to blur completely into dust. Somewhere beyond our reach, something ancient still moves. Quietly, reports began emerging from amateur observatories in Japan, Chile and parts of North America early November, images that did not match expectations from previous observations. No one claimed certainty, only deviation. In astronomy, deviation is enough to draw attention. The object seemed more compact than it should have been, its coma less chaotic, its brightness less diffuse. Nothing dramatic, nothing definitive, but enough to remind those watching that understanding is never guaranteed. Institutional silence deepened the atmosphere of contemplation. Agencies that normally address public confusion quickly remained still, offering no clarifications. This was not the stillness of avoidance, it was the stillness of care. When data does not align easily with established models, the space between receiving and interpreting becomes delicate. Speaking too soon risks misunderstanding. Speaking too late risks losing trust. Thus the pause. But for those outside official channels, the pause carried weight. The cosmos often changes faster than institutions can respond. The observation window continues to move, the comet continues to drift, the world continues to ask questions in the dark. When silence surrounds a subject already layered with anomalies, it becomes impossible not to wonder whether the silence is itself part of the story. Still, caution remains the wisest companion. The leaked images might reflect rare geological behaviour, uneven sublimation, or fragments yet unseen. They may simply be artifacts created by the limits of small telescopes pushing against the edge of their capability. But the possibility that they capture something real, however subtle, keeps the community awake at their screens, exploring gradients and angles as though they contain the first hints of an unspoken truth. In every era of astronomy, anomalies like these have appeared. Some eventually dissolved into natural explanations: unusual dust composition, asymmetric jets, tumbling rotation states. Others widened our understanding of comet behaviour and expanded the boundaries of what we considered normal. Very few forced us to rewrite old assumptions and accept that the cosmos does not owe us familiarity. For now, what matters most is not the conclusion but the noticing, the willingness to pay attention to a soft disruption in the expected pattern of light, the patience to sit with uncertainty as though it were a companion rather than an adversary, the humility to accept that even with our instruments, algorithms and models, the universe still moves according to principles older than our questions. It is all right not to understand. Understanding takes time, and time belongs to the stars more than to us. The sun has already shaped Three-Eye Atlas once, and it will shape it again as it continues outward. The comet, or whatever it truly is, drifts on, shedding what it must, revealing what it chooses, withholding what it cannot yet show. And we, standing beneath a sky that never asks permission to remain mysterious, look upward with quiet persistence. Tonight the universe whispers again, and somewhere beyond our reach, something ancient still moves. As the discussions around the leaked images continued, a deeper question began to take shape, one not about authenticity, but about timing. These photographs did not surface in a vacuum. They emerged precisely when Three-Eye Atlas re-entered observable positions after weeks of silence behind the sun. Such moments often carry heightened significance in astronomy, because reappearance reveals what the solar encounter has changed. And this time, the changes were not subtle. The object looks different, not dramatically, yet unmistakably enough to stir a quiet tension among those who study celestial bodies with patient devotion. The sun has always been a sculptor of comets. Its radiation strips reshapes and sometimes destroys them entirely. But the peculiar clarity some observers claimed to see in these November images contradicted the expected post-perihelion behaviour. Instead of becoming more diffuse, Atlas appeared at least some eyes more defined. Instead of shedding structure through violent sublimation, it seemed to whisper outlines where outlines should not survive. It was as though the sun had burned away only what concealed the deeper shape, not the shape itself. Comparisons between the verified September imagery and the circulating November captures intensified curiosity. The earlier photographs showed exactly what astronomers expect: a hazy nucleus wrapped in a growing coma, its edges blurred by the constant release of dust. But the alleged November imagery introduced something almost dissonant: features that appeared to persist across frames, maintaining position and brightness, even as the surrounding glow shifted. Whether real or artifact, the idea that such consistency could survive the turmoil of perihelion challenged long-held assumptions. Those who process astronomical images know the fragility of interpretations. A slight adjustment in contrast, a small shift in threshold filtering, and patterns appear or vanish like brief dreams. The challenge is recognizing which patterns are illusions and which hint at deeper truths. Analysts approach the Atlas data with the caution of people aware that the universe often misleads through complexity rather than deception. Every enhancement became an act of patience. Every contrast curve a quiet attempt to listen to what the light was trying to say. Some observers reported that when stacking images from different nights, faint lines seemed to align across the frames. Not straight, not artificial, but oddly consistent in their angles. Others rejected these claims entirely, attributing them to compression, noise lens diffraction, or over-processed data. Yet the conversation persisted because ambiguity itself demanded attention. The universe rarely speaks in certainty. More often it offers echoes and invites interpretation. Silence is the universe thinking. Universe. Meanwhile, amateur astronomers across Asia and South America reported their own observations, subtle deviations from the September profile that could not be dismissed outright. Some noted that the coma looked more lopsided, as though material was venting unevenly. Others documented brief fluctuations in brightness that did not match predictions. Individually, each observation could be explained. Collectively, they formed a pattern that leaned away from routine cometary physics. There is something profoundly human about gathering small anomalies and trying to see whether they form a coherent constellation of meaning. Across forums and quiet observatories, people began tracing the outline of a question: what exactly was passing through our sky? Not in a sensational sense, not in fear, but in the contemplative realization that nature still holds forms we have not yet named. Somewhere beyond our reach, something ancient still moves. Amid this growing curiosity, institutional silence continued. It would be easy to interpret this as concealment, but silence in scientific institutions often reflects caution rather than secrecy. Data must be verified, models must be tested, and interpretations must withstand scrutiny before they can be shared with the world. Especially when the subject carries public interest capable of spiraling into misunderstanding. In that sense, silence can be a gesture of responsibility, not avoidance. Still, the contrast between public debate and institutional quiet created an atmosphere heavy with possibility. The absence of official commentary allowed hypotheses to stretch further than they normally would, yet many researchers remained grounded, reminding one another that unusual does not mean unnatural. Atlas could simply be a comet of uncommon composition, one shaped in a different solar nursery, carrying elements unfamiliar to instruments tuned for local patterns. Some speculated that the object might be fragmenting internally without producing visible debris fields. Others suggested that the coma might be shaped by jets emerging from deeper layers, exposed at perihelion. In this scenario, the seeming structure in the images could reflect energetic activity rather than physical form, a dance of gas rather than geometry. These explanations were not designed to dismiss wonder. They were efforts to honour it through discipline. And yet a quiet part of the scientific mind always remains open to possibility. For decades, astronomers have encountered objects that forced them to revise assumptions, asteroids that behaved like comets that carried unexpected minerals, interstellar fragments that arrived with trajectories defying easy reconstruction. It is a reminder that the cosmos does not arrange itself according to our frameworks. Our frameworks adapt to the cosmos. It's all right not to understand. Those watching Atlas closely began to treat the observation window as an opportunity rather than a mystery. The more images collected now, the more clarity would emerge in months or years to come when the data could be processed with newer techniques. They understood that the night sky often reveals its lesson slowly. A strange brightening today may find explanation only after comparing hundreds of data sets acquired across the world. A shift in colour may be understood only when catalogued beside thousands of similar observations from other comets. As more amateur observers joined the effort, an informal network formed an unspoken collaboration in which people across continents pointed their lenses at the same coordinates night after night, contributing to a collective archive of light. This distributed approach mirrored the way early astronomical discoveries unfolded: many eyes, many instruments, one sky. No single person could capture the full truth, but together they could contour its outline. What the leaked images ultimately represent, artifact, anomaly, or revelation, remains secondary to the act of observing itself. In watching Atlas, people are reminded of the fragility of knowledge, the humility that science demands, and the deep calm that arises from accepting uncertainty without surrendering curiosity. The cosmos has always been a teacher of patience. It offers no guarantees, only moments of clarity floating between long stretches of unanswered questions. And so Atlas continues its journey unhurried, indifferent to interpretation. Its tail stretches faintly behind it, its nucleus glows with a soft defiance against the cold, and its behaviour, whether ordinary or extraordinary, remains a quiet invitation. The invitation is simple: look upward, pay attention, and allow mystery to exist without urgency. Tonight, the universe whispers again, and in that whisper lies the reminder that not all understanding must arrive at once. The debate surrounding 3 Atlas deepened as observers began revisiting the earliest recorded anomalies from its approach. Long before any leaked photographs appeared, the object had shown patterns that strained the edges of existing models. Its trajectory was clean and hyperbolic, yet the distribution of brightness along that path presented more questions than answers. Some nights the object seemed restless, brightening unexpectedly, then settling into dimmer tones without correlation to solar flux. These fluctuations were subtle yet persistent, and persistence is what draws scientific curiosity like gravity pulling on drifting dust. Astronomers across multiple observatories noted that the object did not simply brighten or dim, it breathed. Its luminosity rose and fell in pulses that lacked the smooth transitions expected from sublimation patterns. Such variations could be explained through rotational effects, but even these models required adjustments that felt increasingly improvised. The universe seldom tailors itself to fit mathematical convenience, and Atlas seemed to remind its observers of this with quiet insistence. Silence is the universe thinking. Colour shifts added another layer to the puzzle. During its inbound journey, the object moved through phases that suggested variable surface exposure or compositional layers reacting differently to solar heating. Yet the timing and sequence of these hues deviated from the familiar patterns comets usually reveal. A reddish tone softened into grey sooner than expected, and the grey, rather than deepening, gave way to blue after perihelion. Blue is not unheard of in cometary physics, but the conditions required for such scattering typically occur under different circumstances. Atlas behaved as though shaped by rules not entirely written in our textbooks. Then came the spectral readings. Hydroxyl emissions appeared in amounts that implied uneven water release. Not impossible, not even unprecedented, but unusual enough to encourage more careful observation. Some speculated that Atlas carried reservoirs of volatile material buried beneath less reactive layers. Others proposed that the object had inherited structural heterogeneity from its origins in another stellar system, where environmental pressures could have been unlike anything seen in our cosmic neighbourhood. Whatever the explanation, the data encouraged humility more than certainty. The deeper scientists looked, the more they encountered these quiet divergences. None large enough to redefine the object alone, but together forming a constellation of anomalies too consistent to ignore. And when the object vanished behind the sun, a collective anticipation formed not merely to confirm predicted changes, but to see whether the irregularities would continue or resolve themselves. In science, resolution is comforting. Persistence is provocative. When the first post-perihelion observations arrived, they revealed a body still encased in ambiguity. The coma surrounding Atlas did not expand uniformly. Jets appeared to activate and fade without clear correlation to rotational phase. The surface brightness map demonstrated a symmetry that resisted stable explanation. These inconsistencies might have been dismissed as atmospheric interference or observational artifacts, but they appeared across independent datasets. Somewhere beyond our reach, something ancient still moves. As data accumulated, comparisons grew more intricate. Observers reviewed the evolution of comets from previous centuries, searching archives for analogues that might illuminate the patterns emerging in Atlas. Some similarities appeared, but none matched closely enough to dissolve the sense of mystery. It was as though Atlas existed at the intersection of known and unknown, a reminder that even in a catalogue of thousands, the cosmos still produces singular behaviour. Scientists approached the problem methodically. They recalculated thermal models, refined dust production rates, and re-examined rotational parameters. But each refinement brought new complexities. Jets that should have appeared dormant showed unexpected strength. Regions predicted to exhibit uniform outgassing instead revealed patchy emission. It was not chaos, but irregular order, a pattern that resisted simplification, without becoming wholly incoherent. Nature often whispers through such complexity, inviting deeper thought rather than quick conclusion. Some hypothesize fragmentation, suggesting that interior structures were exposed during perihelion. This would account for both the uneven emissions and the enhanced clarity reported in some images, but fragmentation typically produces debris detectable in photometric analysis, and no clear evidence of such fragments appeared. Even high-sensitivity observations showed no consistent signature of splitting. If fragmentation had occurred, it behaved in a manner uncharacteristically restrained. Others suggested the possibility of a hardened nucleus denser and more resilient than expected. Such a nucleus could endure solar heating without disintegrating, revealing subsurface layers capable of scattering light in surprising ways. But this theory too faced challenges. A denser core contradicts the expected formation of interstellar objects, which typically arise from loosely bound icy material easier to eject from distant planetary systems. A hardened structure implied forces or histories beyond our familiar models. The community found itself suspended between explanations, none fully satisfactory. Yet this suspension was not frustration, it was wonder. Science advances not only through answers, but through moments when the universe refuses to fit comfortably into the margins of established theory. Atlas was becoming one of those moments. Sometimes the sky offers a question so gentle, so persistent, that the only response is reflection. Amateur astronomers contributing from rooftops and rural fields added texture to the global dataset. Their observations captured nights unobserved by major instruments, filling gaps and offering fresh perspectives. Some noted brightness stabilization where fluctuation was expected. Others detected brief asymmetries in the tail shifting delicately, like threads caught in a cosmic breeze. Their contributions echoed an old truth: the sky belongs to everyone who looks up. The anticipation leading up to November 11th grew like a tide. As the object approached a favourable viewing angle, telescopes were calibrated, scripts prepared, and data channels set to receive new streams of light. Observers knew the significance of this moment. Atlas would be close enough for detailed analysis, yet far enough to remain stable for imaging. What it revealed in those early hours would shape interpretations for years. Each new frame carried the weight of possibility. Some revealed nothing unusual, others contained faint traces that hinted at underlying structure. The debate was not about proof, but about interpretation, what light can tell us and what it cannot. The cosmos often speaks in gradients, not certainties. Silence is the universe thinking. As the observation window widened, one truth settled gently into the minds of those watching. Understanding Atlas would not come quickly. The object was not a puzzle to be solved in a night, but a journey to be followed with patience. Its anomalies were invitations, not warnings. Its silence was not concealment, but the natural quiet of something moving through vast distance shaped by conditions we may never witness. It's all right not to understand. In the end, Atlas continued onward, leaving behind a trail of questions soft as starlight. Some would be answered in months. Others might remain unresolved, drifting gently into the realm of cosmic folklore. But what mattered most was the act of watching, of caring enough to follow a small body across unimaginable space. Tonight the universe whispers again, and those who listen find themselves humbled beneath its patient glow. As the global community of observers continued collecting data, a subtle pattern emerged, one that did not rely on any single anomalous reading, but arose from the accumulation of small persistent deviations. Each slight irregularity in brightness, each unexpected fluctuation in spectral signatures, each inconsistent development of the coma seemed trivial in isolation. Yet taken together they formed a mosaic that resisted simple categorization. Atlas was behaving like a comet, yet not entirely. It followed known physical laws, yet always with a faint divergence that kept researchers awake longer than their instruments. The more the data flowed, the more scientists began speaking in careful metaphors. Some described Atlas as hesitating in its responses to solar radiation, as though the object reacted in delayed rhythms rather than in direct correlation to energy input. Others likened its outgassing to a form of uneven breathing, where one hemisphere appeared more active while the opposite remained mysteriously calm. Such metaphors are the refuge of minds grappling with phenomena that slip through the cracks of mathematical language. Silence is the universe thinking. In late-night labs, researchers revisited archival observations of known comets, searching for historical echoes that might cast light on the present puzzle. Some comparisons offered partial insight. Objects like 2I Borisov displayed unexpected fragmentation patterns, while Oumuamua revealed a non-gravitational acceleration that sparked years of debate. Yet neither provided a complete template for Atlas. This new visitor appeared to occupy a narrow space between categories, its behaviour familiar enough to recognise yet foreign enough to unsettle. Meanwhile, the conversation around the leaked images evolved. The initial shock had softened into contemplation. Analysts began treating the photographs not as revelations, but as artifacts requiring context opportunities to probe deeper questions rather than leap to premature conclusions. Some images were quietly dismissed as over-processed. Others continued to linger in the collective mind, not because they proved anything, but because they refused to disappear under scrutiny. Somewhere beyond our reach, something ancient still moves. Professional astronomers remained cautious. They emphasized the limitations of small aperture imaging, the dangers of compression artifacts, and the ways optical noise can mimic structure. Yet even their cautions carried an undertone of curiosity. If the features identified in certain frames were indeed illusions, why were they appearing consistently across independent datasets? If they were real, why did the object maintain such coherence after its violent solar encounter? The conversation unfolded like a quiet meditation, drawing participants deeper into contemplation rather than conclusion. At the same time, an unexpected development emerged. A handful of observatories reported rotational irregularities, subtle, nearly imperceptible changes in the object's spin state inferred from photometric analysis. Rotation is a comet's heartbeat. It reveals mass distribution, internal structure, and the influence of sublimation jets. For Atlas, the heartbeat seemed to shift unpredictably, slowing slightly on some nights and accelerating on others. These deviations were small enough to be debated, yet persistent enough to be acknowledged. They hinted at an internal complexity not easily modelled. Some speculated that the object might contain pockets of material denser or differently composed whose exposure triggered momentary changes in torque. Others suggested unseen vents beneath the surface, releasing gas in uneven pulses. All explanations remained tentative, offered gently like hypotheses placed on a table, rather than asserted as truths. It's all right not to understand. the greatest discoveries often begin with delicate questions rather than bold claims. As the calendar approached mid-November, anticipation grew. The object moved into a region of the sky more accessible to northern observers, dramatically increasing the volume of incoming data. New telescopes entered the conversation, each with unique sensitivities that add nuance to the overall picture. Some captured faint extensions of the tail stretching farther than expected. Others identified subtle asymmetries in the coma distribution. Tiny discrepancies persisted quiet as dust motes drifting in starlight. These observations deepened an emerging perspective Atlas might be neither anomaly nor outlier, but teacher. A reminder that interstellar objects shaped in environments distant and unknowable may carry behaviours rarely seen in our local neighbourhood. Perhaps what seems strange now will one day become familiar after hundreds more such bodies pass through the inner solar system. Perhaps Atlas is not unusual, perhaps our sample size is simply too small, yet mystery remains a gentle companion. The more we learn, the more we refine our ignorance. Scientists often say that uncertainty is the oxygen of discovery, and Atlas offered an atmosphere rich with it. Every night brought new data and new reasons to revisit earlier assumptions. The object seemed almost alive, not in the literal sense, but in the sense that it refused to remain static under observation. Like all things shaped by entropy and time, it evolved in ways that eluded quick explanation. And so the community waited, continued observing, continued asking new questions with old humility. No single frame, no single spectrum, no single anomaly defined the object. Instead, Atlas became a meditation on complexity, on the quiet truth that the universe does not answer to our expectations. It reveals itself only in fragments, in pulses, in the soft cadence of celestial motion. As November nights lengthened and the air grew sharper, telescopes across continents turned toward the same patch of sky. What they captured varied in clarity, but not in purpose. Each image was a gesture of human curiosity, a recognition that even in a vast and ancient universe we continue to seek understanding with instruments built from hope as much as from metal. Tonight the universe whispers again, and those who listen feel themselves carried gently into the quiet depth of its unanswered questions. As November unfolded, the observation window widened, and a new thread of inquiry appeared within the scientific community, one that focused less on the leaked photographs and more on the deeper physical behaviour of Three-Eye Atlas. Researchers began noticing that the object's coma did not expand as uniformly as expected. Instead, it seemed to pulse, growing in sudden bursts and then settling into moments of strange stillness. This oscillation did not match the regular sublimation cycles driven by solar heating. It resembled something more irregular, almost as if the comet responded to internal processes, rather than solely to external forces. Analysts studying high-resolution spectra found hints of asymmetry in the gas distribution. In particular, the hydroxyl signatures detected earlier in the month appeared in patterns that defied simple interpretation. Some areas exhibited strong release, while others remained unexpectedly quiet. This uneven distribution suggested the possibility of localized reservoirs beneath the surface pockets of volatile material releasing in unpredictable rhythms. Such behavior is not unheard of, but the scale and persistence of the patterns challenged familiar expectations. The deeper scientists looked, the more Atlas behaved like a layered object, its surface and subsurface reacting to solar exposure in ways that hinted at structural variation. Some layers seemed fragile and quick to respond, while others appeared more resilient. The result was a comet that did not merely dissolve under sunlight, but revealed itself gradually, piece by piece, like a slow turning page in a story written across interstellar distances. Silence is the universe thinking. Meanwhile, observers continued refining photometric measurements, tracking how the object rotated over long sequences of images. The rotation rate seemed strangely inconsistent. Some nights suggested a slow, steady spin. Others hinted at subtle accelerations or decelerations. These irregularities could have been observational noise, yet the consistency of the pattern across independent datasets suggested otherwise. Something was shaping the spin state, something dynamic unfolding beneath the visible layers. One hypothesis proposed that Atlas might possess an uneven internal mass distribution. If denser materials lay hidden beneath lighter, more volatile outer layers, The sublimation of specific regions could exert momentary torque, altering the rotation. This would explain the small periodic deviations detected in the light curves. Yet even this explanation required assuming a level of internal complexity uncommon in known comets. Somewhere beyond our reach, something ancient still moves. At small observatories across Europe and North America, new data emerged showing faint transient jets appearing at the limb of the nucleus, brief outbursts that vanished within hours. Some were too small to shape the general appearance of the coma, but significant enough to shift brightness in measurable ways. These jets seemed to fire unpredictably, driven not by uniform solar heating, but by internal ruptures, as though Atlas had been storing stress beneath its surface, waiting for the right moment to exhale. Researchers exchanged notes, quietly aware that a pattern was beginning to form, but also wary of over-interpreting early data. Science moves slowly, and the cosmos moves even slower. Yet the convergence of evidence pointed toward a visitor with a complicated interior, a structure shaped by pressures and temperatures from a star system far from our own. Understanding such a body required patience, and patience was the shared language of all who observed. As new telescopes joined the effort, including several equipped with advanced adaptive optics, fresh images captured subtle variations in the tail structure. The dust stream narrowed unexpectedly on some nights, then widened in gentle arcs on others. These fluctuations suggested shifts in the object's activity levels, aligning with the irregular spin pattern and the uneven sublimation behaviour. None of these phenomena broke the laws of physics, yet each pushed gently against familiar boundaries, challenging the assumption that interstellar comets should behave like their local counterparts. A few analysts revisited the debated leaked images in this new context. They wondered whether the apparent structure visible in certain frames might not indicate artificial geometry, but instead reflect natural subsurface strata exposed during perihelion. Solar heating could have stripped away outer layers, revealing deeper components of differing density or reflectivity. In this interpretation, the object was not mysterious, because it was unnatural, but because it carried the geological memory of a distant world. Others argued that even this interpretation required caution. Post-perihelion effects vary widely across comets, influenced by size, spin, state, and composition. The patterns seen in the images might result from the angle of observation, the scattering of light, or the increased clarity afforded by unusually stable atmospheric conditions. As always, multiple explanations remained viable, each beautiful in its own way, each reflecting the humility with which science must approach the unfamiliar. Still, the fact remained Atlas was difficult to categorize. Its activity levels rose and fell unpredictably. Its coma shape defied the smooth symmetry of classical models. Its spectral features shifted subtly from one night to the next, as though responding to unseen forces within its fragmented heart. And through all these irregularities, observers felt a quiet sense of companionship. With the object, a recognition that mystery is not an enemy, but an invitation. Atlas continued to drift through the pre-dawn sky, its faint glow a reminder that not everything needs to offer clarity to hold significance. Some questions unfold across years, others across lifetimes. The important thing is the willingness to look upward, to follow the arc of a visitor from another star as it passes briefly through our neighbourhood, leaving behind more wonder than certainty. It's all right not to understand. The night sky has always carried answers in fragments, offering them slowly as though waiting for humanity to catch its breath. And so, the observations continued gentle as the hours before sunrise. Each new dataset became a brushstroke in a painting still unfinished, each small anomaly a whisper of the unknown. Tonight the universe whispers again, and those who listen feel themselves drawn deeper into a quiet realm where science meets awe and where uncertainty feels less like a barrier and more like a doorway. As more telescopes turn toward the quiet arc of Three-Eye Atlas, another layer of the mystery unfolded, this time in the realm of brightness stability. Observers began reporting a phenomenon that felt counterintuitive. Certain illuminated regions of the nucleus maintained consistent brightness across multiple nights despite the constant rotation of the object. In a natural comet, such consistency rarely persists as jets of dust and vapour shift with every subtle turn. Yet Atlas seemed to preserve a faint signature of sameness, as though some parts of its surface reflected light with a discipline uncommon to objects shaped by heat and instability. This observation did not declare artificiality. Instead, it hinted at a structure more resilient than expected. Maybe the nucleus possessed unusually compact layers. Maybe reflective minerals lay embedded in fractured ridges. Or perhaps the object rotated more slowly than previously assumed its spin axis, oriented in a way that kept certain features visible for longer intervals. All explanations remained tentative, offered in the same calm breath that accompanies new data still settling into place. Silence is the universe thinking. The more scientists examined this brightness pattern, the more they encountered a subtle but persistent symmetry. Not perfect, not geometric, but rhythmic, almost like the slow beat of a distant drum. Comets typically carry uneven distributions of material, creating a symmetry that reveals itself in their light curves. Atlas, however, seemed to hover between symmetry and chaos. Its brightness oscillated, but with a steadiness that eluded easy interpretation. Somewhere beyond our reach, something ancient still moves. Across online forums, where astrophotographers gather to compare work, individuals began overlaying their exposures from different nights to search for common shapes hidden in the haze. Some found nothing unusual, others found faint alignments, edges that seemed to echo one another from night to night. These overlays sparked no uproar, only curiosity. The community had learned that rushing toward conclusions often obscures more than it reveals. So they approached the faint patterns as one approaches unfamiliar star clusters, with care, humility, and a willingness to accept that the eye sometimes sees truth, and sometimes only longing. Meanwhile, several professional observatories analysed thermal data measuring the object's infrared profile. The readings showed temperature inconsistencies across the nucleus spots, warmer than expected, others cooler, creating a patchwork of thermal contrast. These variations could indicate regions where sunlight struck newly exposed material, or where cavities beneath the surface acted as reservoirs of heat. But some temperature zones remained strangely stable, reflecting sunlight with an efficiency that surprised thermal modelers. The nucleus seemed textured in ways that hinted at both fragility and endurance. As data accumulated, the scientific community revisited one of the earliest questions raised about Atlas. Why did it brighten unexpectedly just before perihelion? Some argued that internal pressure built up beneath insulating crusts, releasing briefly in a jet that increased reflectivity. Others argued that sunlight illuminated previously shadowed material with higher albedo. Both explanations held merit, yet the fact that no debris cloud accompanied the brightening remained a puzzle. Comets often reveal their stress dramatically. Atlas did so with restraint. The absence of fragmentation signatures deepened the intrigue. Observers expected to see small clumps, dust fields, or uneven tail structures, signs typical of a comet under solar duress. But night after night, the nucleus remained mostly coherent, refusing to disintegrate despite conditions known to fracture far larger bodies. Perhaps Atlas held together through sheer density, or perhaps its composition allowed it to dissipate stress in ways uncommon to familiar comets. It was a reminder that some visitors carry histories that our models cannot fully articulate. In the midst of these scientific investigations, an unexpected shift occurred in the public discourse. The leaked images, once the centre of attention, began losing weight, as more grounded anomalies took precedence. The community realised that the true mystery of Atlas did not depend on unverified photographs. It lay in the consistent documentable deviations appearing across legitimate datasets. These deviations painted a portrait of a body shaped by forces both familiar and unknown forces that wrote their signatures in brightness, curves, thermal gradients, and the quiet persistence of structure. As the comet approached its mid-November arc, atmospheric conditions in many regions improved, granting observers clearer skies. New images arrived with remarkable sharpness. Some revealed long, delicate filaments trailing behind the nuclear structures shaped not by violent jets, but by slow, continuous release. Others showed the coma thinning in one direction and thickening in another, as though the object were inhaling and exhaling through unseen vents. Such behaviour suggested internal architecture more elaborate than the simple mixture of ice and dust expected in conventional cometary bodies. It hinted at pockets, fractures, and tunnels, voids carved by ancient heat or pressure in the stellar nursery where Atlas was born. These theories required no leap toward the extraordinary. They simply acknowledged that interstellar objects can carry memories of environments far different from our sun's gentle radiance. Slowly a consensus began to form, not of answers but of approach. Scientists agreed that Atlas should not be treated as an anomaly to explain away, but as a teacher offering insight into the diversity of interstellar bodies. Each unexpected observation became a clue to the conditions of its distant origin. In this light, the object was less a problem and more a message, one written in the language of physics waiting patiently for translation. The nights grew colder as the Earth's tilt deepened, yet observers continued with steady devotion, capturing frames beneath frosted domes and quiet rooftops. The glow of Atlas remained faint but constant, a thread of starlit motion weaving through the dark. It reminded those watching that mystery need not be grand to be beautiful. Sometimes the quiet persistence of data, the soft contradiction of patterns, the slow evolution of an understanding is enough to create wonder. And through it all, Atlas drifted onward unconcerned with interpretation. It shed particles into space the way a tree sheds leaves naturally effortlessly, without the need for attention. The universe does not ask for witnesses, yet it offers itself to them freely. It's all right not to understand. The path of comprehension often begins in the comfort of uncertainty. As mid-November approached, one truth settled into the minds of those studying the object. The deeper they looked, the more Atlas revealed not clarity but complexity. And complexity in the quiet language of the cosmos is a form of generosity. Tonight the universe whispers again, inviting all who watch to follow its mysteries with patience and open hands. As the observation window moved toward its peak, a new layer of inquiry began unfolding, one focused not on brightness or colour, but on motion. Analysts studying long exposure frames noticed something subtle. The tail of 3i Atlas did not drift consistently with the solar wind. Instead, it shifted in delicate variations, sometimes bending more sharply than predicted, other times flowing with an unexpected smoothness. These deviations were small, almost quiet, yet persistent enough to suggest that the dust flow was responding to forces not immediately obvious. Silence is the universe thinking. Solar wind typically shapes comet tails with predictable elegance, pulling dust and ionized particles into long, graceful arcs. But Atlas seemed to resist this simplicity. Some nights its dust tails stretched thinner than expected, tapering as though constrained by an unseen boundary. Other nights it widened without clear provocation, as if the comet exhaled differently, depending on the internal state of its nucleus. These behaviours did not violate physics, they simply stretched its edges. Somewhere beyond our reach, something ancient still moves. Researchers recalculated expected tail curvature using updated solar wind models, but the adjustments only partially aligned with real observations. The remaining discrepancies hinted that Atlas might be releasing dust in pulses rather than in a steady stream. If true, this meant the nucleus possessed internal pressure pockets, cavities releasing material episodically. Such pockets would imply a more complex geological structure, perhaps shaped by conditions from an unfamiliar stellar nursery. Interstellar objects, after all, do not owe us a resemblance to local comets. At amateur observatories, long exposure imaging provided further insight. Some individuals captured faint secondary wisps branching subtly from the main tail, delicate feather-like extensions that vanished in shorter exposures. These wisps suggested that dust of varying grain sizes was being expelled at different velocities. In classical comet behaviour, such differentiation occurs, but rarely with such visible separation. Atlas seemed to sort its own dust, letting heavier grains fall behind like quiet echoes of its past. Meanwhile, spectroscopic analysis from small university observatories detected fluctuations in ion tail composition. On certain nights, emissions associated with carbon-based molecules appeared stronger than expected. On others, they diminished. These oscillations mirrored earlier anomalies in brightness and rotation, reinforcing the idea that Atlas's behaviour followed not a smooth continuum, but a series of internal rhythms. It's all right not to understand. The universe does not reveal its patterns all at once. These irregularities did not disrupt the broader scientific narrative. Instead, they enriched it. Researchers realized that Atlas provided a rare opportunity, a chance to observe how a body from another star system responds to conditions unique to ours. In this sense, its deviations were not merely puzzles, they were gifts. Each unexpected turn-in-tail structure became a clue to the environment in which the object once formed. Perhaps its parent star produced different radiation pressures. Perhaps its surface layers evolved under temperatures unlike those found in our region of the galaxy. As the nights grew deeper and colder, observers stitched together data from across continents, forming composite timelines of the tail's evolution. In these visual mosaics, patterns emerged: moments of calm followed by sudden shifts, stable arcs interrupted by irregular flares. Nothing in these patterns indicated artificial influence. Everything pointed toward complexity, and complexity in the language of the cosmos is simply the residue of long histories. Toward the final weeks of November, the tail began lengthening dramatically as the object moved farther from solar glare. With greater distance came greater clarity. Some frames revealed faint striations within the dust stream, thin lines of differing density that moved like threads woven through a celestial tapestry. These striations suggested layered ejection events, each leaving its own mark on the comet's luminous trail. Scientists quietly marveled at these formations, recognizing in them the signatures of a world they would never see. Through all of this, Atlas remained indifferent. It continued its arc across the sky, shedding particles shaped by forces older than our civilization, older even than our sun. Those who watched were reminded that wonder often resides not in dramatic revelations but in quiet deviations, the soft shifting of a tail, the gentle brightening of a nucleus, the subtle widening of a dust plume. Tonight the universe whispers again, and those who follow its faintest movements find themselves humbled by how much remains unknown. As observations accumulated through late November, attention began shifting toward the deeper question of origin. What kind of stellar environment could have shaped an object as complex as 3 Atlas? Interstellar visitors are rare, yet each one carries within it the geological memory of another sun, another planetary nursery. To study such an object is to peer backward across millions of years, tracing faint clues left in dust gas and motion. Atlas offered no clear answers, only quiet hints that invited reflection. Silence is the universe thinking. Researchers revisited early spectral readings, focusing on the ratios of minerals and volatiles detected in the coma. Some results aligned with familiar models: water, carbon, rich compounds, faint traces of metals. But other readings carried subtle irregularities, shifts in emission lines that hinted at formation conditions different from our own system. Perhaps Atlas formed closer to its parent star or farther away. Perhaps that star emitted different wavelengths, leaving chemical imprints now dissolving into the night. Somewhere beyond our reach, something ancient still moves. These speculations were not leaps into fantasy. They were quiet extrapolations grounded in data. Volatile distribution revealed a layered structure, as though the object accumulated material during multiple epochs of its stellar nursery. Some layers reacted quickly to sunlight, sublimating with a soft brightness. Others resisted heat, longer releasing gas slowly, almost reluctantly. This stratification suggested a history of shifting environments. Dust clouds, thick and thin, radiation fields, strong and weak. Atlas was not a simple relic. It was a traveller shaped by complex origins. Meanwhile, dynamical experts examined the object's trajectory with renewed care. Its hyperbolic path was expected, but tiny deviations within that path raised intriguing questions. These deviations were not signs of artificial propulsion. They were too subtle, too irregular. Instead, they might hint at asymmetric outgassing, or internal shifts affecting momentum. Such variations offered indirect clues about its internal structure, much like the wobble of a spinning top reveals imperfections unseen to the eye. Atlas whispered its secrets not through clarity, but through the softness of its irregular motion. Some wondered whether the object might once have been part of a larger body, a fragment torn from a parent world during ancient collisions. If true, its layered structure and stubborn cohesion could be remnants of deeper geological strata. Yet such speculation remained gentle, cautious. The cosmos has its own vocabulary, and humanity must learn it slowly. It's all right not to understand. As models evolved, researchers also considered the possibility that Atlas came from a binary star system. In such systems, gravitational interactions produce complex temperature gradients and volatile distributions, creating bodies unlike anything formed around solitary stars like ours. A binary origin could explain the uneven composition, the thermal irregularities, and even the enigmatic behaviour of the coma. But proof remained distant, hidden within signatures too soft for current instruments to decipher fully. A cross-observatory's interest grew in comparing Atlas to Oumuamua and Borisov, the only two other interstellar objects ever observed. Where Borisov behaved much like a typical comet, Oumuamua defied categorization with its shape and acceleration. Atlas seemed to straddle a space between them, more structured than Borisov, more stable than Oumuamua. It belonged to no clear category, yet touched the edges of several. The universe, it seemed, was reminding observers that classification systems are conveniences, not laws. Amateur astronomers contributed their part to this inquiry, analysing dust flow patterns to infer historical pressures on the object. The thickness of the tail, the density of grains, and the spread of the coma suggested long-term exposure to radiation environments harsher than those in our solar system. Atlas might have spent eons drifting through interstellar voids, its surface sculpted by cosmic rays and micrometeor impacts, its structure toughened through quiet endurance rather than violence. Some researchers proposed a poetic idea that the object might be older than Earth, older even than the Sun. Such age estimates were speculative, but not impossible. Interstellar comets can wander for billions of years before encountering a system like ours. If Atlas truly carried memories of a time before our world existed, then every grain of dust it shed was a small patient testimony to epochs we will never witness. Still, despite all speculation, humility prevailed. The data did not yet reveal the birthplace of Atlas. It merely hinted at the contours of its long journey. The cosmos teaches slowly, and Atlas was becoming a teacher whose lessons required patience. Scientists learned to appreciate the object not for the answers it provided, but for the questions it encouraged, questions that expanded the imagination without abandoning rigour. As November neared its end, telescopes documented the final stages of the object's approach toward its December arc. Atlas shone faintly in the eastern sky, a reminder that distant worlds send visitors not to shock but to whisper. Understanding would come later. For now, the act of watching was enough. Tonight, the universe whispers again, offering its mysteries with the quiet confidence of something older than comprehension. As December approached, the collective attention of observers sharpened. 3i Atla entered a phase in which its distance, angle and brightness aligned just enough to grant clearer insights into its evolving structure. Long exposure images revealed a nucleus that remained unexpectedly coherent even after weeks of solar heating. Most comets soften under such pressure, their surfaces shedding material until only fragmented structures remain. But Atlas seemed to resist that dissolution. Its light, though faint, carried a steadiness that contrasted with the ragged motions often seen in post-perihelion bodies. Silence is the universe thinking. Analysts compared frames taken days apart, tracking the subtle outlines that defined the nucleus. What they found was peculiar. Some contours barely shifted even when the tail behaved erratically. This persistence suggested that beneath the haze of gas and dust, the object retained a stable geometry. Not crisp, not mechanical, but steadier than expected. It hinted at internal cohesion. Perhaps a dense core, perhaps layered strata, bound together by processes forged long before our sun existed. Somewhere beyond our reach, something ancient still moves. Thermal data added another dimension to the story. Infrared readings captured across multiple observatories revealed fluctuating surface temperatures, but with surprising continuity in deeper layers. The warmth radiating from Atlas cooled predictably each night, yet certain regions retained heat longer than they should have. This retention suggested materials with different thermal inertia, as though the nucleus contained minerals capable of storing energy more effectively than typical cometary ice. It encouraged researchers to consider whether Atlas originated in a region with strong radiation fields or in conditions that allowed unusual chemical compounds to form. spectroscopy teams noted that the object's signatures fluctuated with irregular cadence. Some nights produced strong carbon chain emissions, others revealed diminished levels. Water vapour signals pulsed inconsistently, as well echoing earlier anomalies in coma activity. But what fascinated scientists most was not the variability, it was the pattern beneath it. The changes did not follow random chaos. They felt rhythmic, like slow tides rising and falling under a hidden gravitational influence. It's all right not to understand. Meanwhile, the behaviour of the tail grew more intriguing. Ionised particles streamed outward in a direction slightly offset from predictions confirming earlier suspicions that Atlas interacted with the solar wind in ways not entirely accounted for by standard models. Dust grains separated into layers of differing thickness, creating soft striations that flowed like brushstrokes across the night sky. These layers often appeared subtly braided, suggesting that ejection events occurred in sequences rather than in uniform expansion. Each braid became a testament to past activity, a fleeting record of internal cycles now dissolving into space. As these findings emerged, a quiet shift occurred among researchers. Rather than forcing Atlas into familiar categories, they began allowing it to define its own. It was neither a conventional comet nor a complete outlier. Instead, it occupied a delicate position between them, a bridge that expanded the vocabulary of interstellar behaviour. This shift was not resignation but liberation. Once freed from the need to classify Atlas quickly, scientists found deeper appreciation for its complexity. Alongside professional efforts, the global network of amateur astronomers continued to refine their contributions. Observers from rural valleys, mountaintop shelters and city-edge balconies documented the object night after night. Some captured subtle asymmetries in the coma, others recorded faint jets escaping at strange angles. Many reported moments when the object's brightness pulsed softly like a heartbeat translated into starlight. These collective observations enriched the growing data set, proving once again that the sky belongs not only to institutions, but to anyone willing to look upward with patience. The question of whether Atlas had undergone internal restructuring during perihelion became a central topic of debate. Some models suggested that subsurface layers may have cracked under thermal stress, releasing new material that altered both rotation and outgassing. Others proposed that perihelion acted as a cleansing moment, burning away superficial ice and exposing more resilient material beneath. Whatever occurred the weeks following perihelion demonstrated one truth. Atlas evolved actively, not passively. Rotation analysis reinforced this notion. When light curves from early November were compared with late November readings, subtle deviations appeared in the periodicity. These deviations were too small to signify extreme change, yet too regular to dismiss. They implied that the object's internal mass distribution had altered slightly, a shift akin to a figure skater extending or retracting their arms to change spin. Such behaviour was not mysterious, only rare, and its rarity deepened the enchantment surrounding the object. As December neared, researchers began acknowledging that some characteristics of Atlas might never be fully resolved. The object would slip away, soon retreating into the cold, wide dark between stars. What remained was a limited window, a brief chance to gather as much insight as possible into a body carrying the geological memory of a distant world. The approaching closest approach on December 19th did not promise clarity. It promised fleeting opportunity. This realization gave the observations a deeper emotional dimension. Many astronomers spoke of the object not as a problem to solve, but as a guest passing quietly through our cosmic neighbourhood. Its riddles were not demands, they were offerings. Each anomaly was a reminder that the universe remains larger than our interpretations, older than our questions, and more patient than any human effort to define it. As the final nights of November slipped into December, telescopes captured some of the clearest images yet. These frames showed Atlas wrapped in a halo of soft, intricate structure, part dust, part vapour, part starlight, reflected from surfaces shaped across unimaginable distances. In each image, the object felt both fragile and enduring, a contradiction that seemed to embody the very nature of interstellar wanderers. And so Atlas continued its quiet journey, indifferent to debate yet generous in mystery. Those who watched from Earth found themselves reflecting not only on the object, but on the broader truth it represented that understanding is not the prerequisite for wonder. Sometimes the cosmos invites us not to conclude, but simply to witness. Tonight the universe whispers again, and in its whisper lies an invitation to remain curious within the dark. As December unfolded, a subtle shift washed through the global conversation surrounding 3i Atlas. It was no longer driven by speculation or debate, but by a growing sense of acceptance, an understanding that the object would soon move beyond the limits of close observation. With each passing night, the angles changed, the brightness softened, and the tail stretched farther into the dark. What had once felt urgent now felt delicate, like holding on to the final notes of a fading melody. Silence is the universe thinking. Researchers approached this last arc of observation with renewed focus. They knew that the data gathered during these final weeks would shape the long-term record, the archive that future astronomers would revisit when attempting to understand interstellar wanderers. Every reading mattered. Spectral lines, brightness curves, thermal signatures, tail morphology. All of it became part of a fragile mosaic, one that would lose detail once Atlas drifted too far from Earth. The urgency was gentle but real. Some of the most intriguing insights during this period came from refinements in the rotation models. As researchers stacked late November and early December exposures, they noticed that the subtle irregularities in the spin state were stabilizing. Whether this reflected internal settling exhaustion of volatile reservoirs or simply an alignment of observational angles remained unclear. But the smoothing of the rotation curve suggested that whatever internal shifts had occurred earlier in the journey were now approaching equilibrium. Somewhere beyond our reach, something ancient still moves. Thermal readings reinforced this sense of quiet stabilization. Regions that once retained heat disproportionately began cooling more uniformly, hinting that the layers exposed during perihelion had finally adapted to their new state. Some scientists proposed that Atlas had shed much of its thermally sensitive material, leaving more stable compounds behind. Others suggested that internal cavities venting earlier, outgassing had collapsed, altering the surface texture. Whatever the explanation, the object appeared calmer, still evolving, but gently. As new high-resolution imaging arrived from mid-latitude observatories, a fascinating pattern emerged in the dust tail. The braided striations observed in previous weeks became more pronounced, stretching across longer arcs with clearer definition. These striations resembled layered timelines, each capturing a moment of release from the nucleus. In their delicate patterns lay the history of Atlas's interaction with sunlight, slow, cumulative, expressive. They read like ancient handwriting drifting across the void. Observers also documented the faint emergence of an anti-tail, a thin forward-facing dust structure caused by perspective rather than physical reversal. Anti-tails appear only under specific geometric conditions, and their presence often reveals details about dust grain size and velocity. For Atlas, the anti-tail was subtle, but significant. Its faint glow suggested larger dust particles mixed within finer material, a combination implying slow measured ejection rather than explosive release. This was another quiet sign of internal restraint. At the same time, a renewed interest formed around the earliest anomalies. Scientists revisited the puzzling colour shifts, the irregular brightness spikes, the non-uniform hydroxyl emissions. These features were now interpreted not as clues to something extraordinary, but as the natural outcome of a complex interstellar object adapting to an unfamiliar star. The Sun had reshaped Atlas, and Atlas had responded with behaviours that stretched models without breaking them. It's all right not to understand. Across the world, amateur astronomers continued to contribute frames infused with their own quiet devotion. Their images, stitched together with professional datasets, revealed a nearly continuous timeline of the object's evolution, something rarely achieved, even for local comets. These collaborative efforts would later become a testament to how deeply the global community had cared about this brief visitor from afar. The cosmos may teach slowly, but people learn quickly when united by wonder. By early December, a new consensus emerged. Atlas was not extraordinary because it defied nature, but because it revealed how broad nature's spectrum truly is. The object demonstrated that interstellar comets could be more layered, more complex, and more structurally resilient than previously imagined. It reminded observers that the universe is filled with materials forged under unfamiliar pressures, shaped by distant gravities and weathered by radiation fields unlike our sun's, such diversity is not an exception, it is a quiet truth waiting to be witnessed. As the object approached the date of closest passage, telescopes captured what were likely to be the final clear views, a nucleus softened by the miles, a tail stretched into a luminous ribbon, and a faint halo marking the slow fading of activity. These images held a gentle melancholy. They represented the last opportunity to observe Atlas, before it receded into distances where only the largest instruments could follow. The night sky has a way of reminding us that observation is temporary, but reverence can be lasting. Scientists in their reflections began to shift focus from immediate data to long-term implications. What might Atlas teach about the formation of planetary systems different from our own? How would its layered structure inform theories of volatile distribution in distant nurseries? Could its resilience offer clues about the diversity of interstellar debris? No single answer emerged, but the questions themselves held value, guiding future inquiry like stars guiding ancient navigators. As December's nights lengthened and the object dimmed, many found themselves experiencing a kind of quiet gratitude. Atlas had arrived without warning, carried mystery without arrogance, and drifted onward without disruption. It left behind data inspiration and a reminder that even in a technologically advanced age, the cosmos retains its ability to surprise. Tonight the universe whispers again, and those who hear it find themselves softened by the reminder that wonder does not require understanding, it requires only attention. As the final days before closest approach unfolded, researchers found themselves reflecting not only on the data collected, but on the nature of uncertainty itself. Thruti Atlas had become more than an astronomical object. It had grown into a quiet companion to long nights, a reminder of how the cosmos reveals its truths in fragments rather than declarations. The object's glow softened slightly with each passing dawn, signalling its gradual retreat into deeper space. Yet even as it drifted away, the questions it raised remained luminous. Silence is the universe thinking. In the last coordinated observation campaigns, astronomers began noticing that Atlas's activity levels had steadied. Jets, once irregular, now seemed predictable, though still gentle. The rotations that had fluctuated earlier in the season settled into a slower, more coherent rhythm. This stabilization mirrored the cooling of a once turbulent system, a natural calming after weeks of solar exposure. It suggested that whatever internal processes had been stirred by perihelion were beginning to quiet, leaving behind a structure no longer resisting the sun but adapting to its influence. Somewhere beyond our reach, something ancient still moves. Images from high-altitude observatories revealed faint layers of dust peeling away from the main tail, forming delicate veils that drifted slowly into the solar wind. These layers were thin enough to appear only in long exposures, yet consistent enough to indicate gradual release rather than sudden outburst. Their presence implied that small fractures along the object's surface continued to vent material, perhaps revealing the final pockets of volatile compounds that had survived the intense heat of perihelion. Each veil was like a soft exhale, a sign that Atlas was quietly shedding the remnants of its long journey. Spectroscopic studies during these final nights added nuance to the object's chemical portrait. Some emission lines weakened as expected, but others persisted longer than models predicted. Particularly puzzling were the sustained traces of complex carbon-bearing molecules typically destroyed quickly by solar radiation. Their persistence hinted that Atlas possessed sheltered layers or deep fissures shielding material from immediate exposure. This raised new hypotheses. Perhaps the object's internal structure was more labyrinthine than previously assumed, composed of chambers and folds shaped by processes from an ancient star system. As the object grew fainter, researchers also turned attention to its long-term trajectory. Simulations projected that Atlas would not return. Its hyperbolic path ensured it would leave the solar system forever once it passed beyond the gravitational influence of the outer planets. This realization introduced a gentle melancholy. Observers understood that the opportunity to study such an object was fleeting, a brief intersection between its vast wandering timeline and our own small moment of awareness. It's all right not to understand. At community observatories, the mood grew contemplative. Amateur astronomers who had captured nightly data since early November felt a sense of closure approaching. Many spoke of how the object had reshaped their sense of scale, how watching something that originated around another star had shifted their understanding of distance, time, and fragility. Atlas became a kind of cosmic meditation, a reminder that the sky is not static but constantly weaving stories across epochs. The faint streak in their telescopes was not merely dust and ice, it was the residue of forces older than Earth. The scientific community echoed this sentiment. In conference calls and email threads, researchers described Atlas as a bridge object, one that connected previous interstellar visitors with conceptual frameworks still forming. Borisov showed how familiar interstellar comets could be. Oumuamua revealed how strange they could become. Atlas lived in the middle ground, refusing both extremes, reminding observers that the universe rarely presents itself in absolutes. Its complexity lay not in dramatic anomalies, but in subtle, persistent deviations that stretched models gently but meaningfully. As December 19th approached the date of closest passage, new attention focused on potential last-minute observations. Some hoped to capture refined rotational data. Others aimed for deeper spectral readings. A few simply wanted one more clear image, a final imprint of the object, before it slid beyond reach. Yet everyone understood that the most profound insights might not emerge now but later when the accumulated data from November and December were studied in retrospect. Atlas was not a mystery to be solved in real time. It was a puzzle destined for years of analysis. By mid-December, the object's brightness had dimmed further, but its tail still reached impressively across long exposure frames. It resembled a quiet brushstroke against the night, a reminder of motion through silence. The tail's faint branching patterns, once subjects of debate, were now seen as signatures of layered outgassing events, each marking a moment in the object's story. These structures would soon diffuse, leaving only the memory of their shape within archived images. The final coordinated observation session took place under skies clear enough to reveal stars down to the faintest magnitudes. In the resulting images, Atlas appeared serene, almost gentle. The nucleus was soft around the edges, the dust halo thin but present. The tail elongated into a luminous thread. It no longer carried the restless energy recorded weeks earlier. It had settled into the quiet dignity of an object completing its encounter with the sun, prepared to continue its journey outward into darkness. As the last data files were saved and the final shutters closed, a sense of gratitude threaded through the community. Atlas had arrived unannounced, brought questions without urgency, and offered mysteries without demand. It reminded humanity that cosmic discovery is not always loud. Sometimes it unfolds as a whisper across early mornings, across frost-covered domes, across screens lit softly in darkened rooms. Tonight the universe whispers again, inviting those who observe to carry its quiet into whatever questions await next. As the final nights of December unfolded, a quiet realization settled over those who had been following 3i Atlas since its earliest detection. The object was beginning to slip beyond the reach of smaller telescopes, its glow dimming as it moved deeper into the outer regions of its trajectory. Observers found themselves spending longer moments at the eyepiece or screen, savouring the last opportunities to witness something that would never return. The sky often teaches through endings, and this ending felt gentle, patient, without the need for dramatic farewell. Silence is the universe thinking. Scientists reviewing the most recent datasets noticed that Atlas's behaviour had entered a final stage of calm. The irregularities that once sparked debate had flattened into smooth curves. The spectral signatures that fluctuated through early November and December settled into faint but predictable patterns. Even the dust tail, once braided and restless, elongated into a soft, unbroken stream. It suggested not resolution but acceptance, a body easing back into its natural state after weeks of solar shaping. Somewhere beyond our reach, something ancient still moves. These changes led researchers to revisit the earliest anomalies not with urgency, but with a sense of perspective. Atlas had not contradicted physics. It had expanded the range of what physics could express. The irregular outgassing, the shifting rotation, the asymmetric heat retention, all of these became not signs of contradiction but signatures of complexity. The object had behaved exactly as one might expect from a visitor forged under pressures unfamiliar to our solar system. In studying it, scientists were reminded that nature rarely conforms perfectly to human expectation. Amateur observers too reflected on their months-long vigil. They recalled the first faint images captured from backyards and rooftops, the excitement of comparing frames across continents, the late-night exchanges filled with both rigour and wonder. Many expressed a gentle gratitude for the object, a sense that through its passage Atlas had brought people together in a shared act of curiosity. Its trajectory had drawn a temporary constellation of human attention across Earth, a constellation held together not by gravity but by quiet fascination. In academic circles, conversations began to shift from immediate interpretation to long-term legacy. Researchers discussed how Atlas would inform future studies of interstellar comets, how its stratified composition could refine formation models of distant stellar nurseries, how its resilient structure challenged assumptions about volatile retention. For many, the object represented a new baseline, not an anomaly but a prototype of diversity. It expanded the imagination of what interstellar visitors might be, offering a glimpse into the vast menu of planetary architectures scattered across the galaxy. It's all right not to understand. As the object approached the final week of meaningful visibility, telescopes began capturing the faintest layers of its remaining activity. Small jets still emerged occasionally, but they were softer now, more like residual breaths than active eruptions. The nucleus no longer exhibited the complex thermal gradients observed earlier. Instead, it radiated a uniform coolness, consistent with an object drifting back toward equilibrium. These observations hinted that Atlas had shed the last of its volatile layers, and now carried only the durable remnants of its ancient history. This quieting did not lessen the object's significance. If anything, it deepened it. Atlas had travelled for perhaps millions of years through the interstellar void, enduring cold beyond imagination, impacts too small to register and radiation fields vast in scale. And yet it survived long enough to be witnessed by a species that only recently learned to measure the sky with precision. That encounter alone was something fragile and profound. In its final appearance through mid-sized telescopes, Atlas resembled a softly fading thread, neither sharp nor dramatic but persistent steady. The coma had thinned to a faint halo, the tail stretched long but delicate, dissolving at its edges like breath in cold air. Observers noted how the object seemed almost serene, drifting outward, with the calm of something that had already endured its greatest trials. The sun had shaped it, revealed it, and now released it back into the dark. For some, these last images inspired philosophical reflection. What does it mean for a fragment of another star system to cross paths with us, only once, then vanish forever into the deep? What stories does it carry in its layered minerals, in its faint spectral lines, in its shifting spin state? What distant forces sculpted it long before Earth ever formed? These questions had no immediate answers, but they evoked a sense of humility, a reminder that the universe holds histories we cannot yet translate. As December drew to a close, the collective observing campaign gradually wound down. Telescopes' cooled lenses were capped and data files were archived for the future. The sky rolled on unconcerned, infinite in its patience. Atlas moved quietly toward the outer boundary of the sun's influence, preparing to re-enter the wide, cold corridors between the stars. It left behind no fanfare, only a trail of dust illuminated briefly by human curiosity. And in its departure, a final lesson settled gently into the minds of those who watched. Some mysteries do not end with answers. They end with perspective. Tonight the universe whispers again, inviting those who followed Atlas to carry forward not certainty but wonder. Traveller. As we reach the edge of this quiet story, the sky feels softer than when we began. The leaked photographs, the strange behaviour, the unanswered questions, they drift now like distant echoes, still unresolved, still shimmering at the edges of what we know. And somehow that feels right. The universe rarely speaks in certainties. It offers hints, small deviations, gentle anomalies that remind us how young our understanding truly is. Thrusi Atlas may leave our skies soon, but its mystery lingers, a quiet thread woven through every telescope pointed into the dark. Somewhere beyond our reach, something ancient still moves. Tonight you've walked beside a story still unfolding, one carried not by fear, but by curiosity, patience and wonder. In the end, that is all the cosmos ever asks of us: to look, to listen, to allow mystery to breathe without demanding it resolve. So let the night settle around you, let the questions rest where they are. The stars will keep their vigil, and the universe will whisper again when it's ready. Rest well, traveller.